Hello, fourth graders. Welcome to our robotics class. This is week 21. So this week we're continuing with the lessons that we've been going through, learning about the engineering design process. So if you remember last week, we went more in detail into defining the problem and finding a solution, right? And so we're going to continue with the same videos that we've been watching. And this week we're going to be learning about variables. So I really would like you to pay close attention because this is something that is pretty new. You might remember we did learn, actually, I don't think we did. We're going to be learning about it. I'm thinking you guys, this is fourth grade. Yeah. So we didn't actually learn about it yet in coding in technology, but we will be learning about that. So this is like a good introduction to that. And it's part of coding and robotics. So I would take notes during the lesson today. So that way you can answer the review sheet. So there is going to be, I've just been making up these short review sheets. And this just helps me to know that you are doing the lesson, since obviously we're not really together to have a discussion about this. This is a good review that I can know that you actually are doing the lesson every week. So definitely jot down some notes. If you even want to have the review sheet opened and just kind of fill in the answers as you're listening to the lesson, that would probably be a good idea. Some of them are just straight questions, some are true or false, and some are fill in the blanks. Okay, so let's continue. And then I'll come back at the end and I'll just kind of remind you what you need to do. Okay, so hang on. Okay, here we go.
Process. So it's one that we kind of fortunately don't have to mess with today because I have zero idea about how to build or fly a hang glider. And anyway, remember that this is a totally fake made-up solution. Don't go jumping into a canyon or anything with a tent, okay? We're here to solve problems, not create new ones.
We've talked about problems.
And hey, we've all got them.
But there are other things we need to understand if we're going to be good engineers. One of the biggest concepts we need to tackle is variables. What can we change and what can't we change when testing our problems? Everyone gets a case of the what if sometimes.
You know, how you ask yourself questions like, what if I run out of popcorn and the movie's not over yet? Or what if it's raining when I walk home from school and I forgot my umbrella?
The threat is real, people. But you know who asks themselves what if questions every day?
Engineers.
These kinds of questions are really important when you're trying to come up with possible solutions to a problem. Like, what if we try to cross a gorge by building a hang glider from a tent?
Remember that?
To come up with solutions to problems like crossing a gorge, you already know that engineers use a series of steps known as the trusty engineering process.
A quick recap.
We started by defining a solvable problem. In our case, how can we get across the gorge? We looked at more than one solution and chose a solution that met our criteria. It used the materials we had available and it would successfully get us across the gorge in one piece. Plus, we could reuse the pieces afterward. Then, in the real world, an engineer would build a prototype of the solution and test a bunch of prototypes before actually using it. And if the solution didn't work, they'd go back to the drawing board. Engineers are not quitters. And there's something else engineers do during the process that we haven't talked about yet, and that's defining variables.
Excellent. So now we just need to figure out what variables are.
A variable is just a condition or a value that can be changed. And sometimes a variable is something we can control, where we, as engineers, do the changing. But other times, variables are totally out of our control. So, say we want to see how high a ball bounces after it hits the ground. Let's identify some of the variables involved in that. We can change the height from which we drop the ball, or we can change the kind of ball we drop. Those are conditions we can change. But one thing we can't change is the gravity that pulls the ball towards the center of the earth after we drop it. That's not a variable we can control.
Now, what about our attempt to cross that giant gorge?
What are the variables there? First, let's think about the variables that we can control. One variable we can change is the weight of our hang glider. We can reduce the weight that it has to carry by, say, leaving our umbrella behind. Or we can add more weight by asking Catbot to hitch a ride. We can also change part of the hang glider's design. If you've ever built a paper airplane, you know that you can change things like the size or the angle of the wings. These things affect how far or high the airplane flies. The same goes for a hang glider. What about variables we can't control? Let's talk wind. The wind over a gorge can be nice and breezy. It can also be forceful during a storm, but we can't control that. Sorry. Also, just like bouncing a ball, we can't control gravity. Now, whether we can control the variables or not, once we've identified what could possibly change when we're trying to solve a problem, we can start asking what-if questions. Like, what if the wind speed is higher than normal? Or what if we decide to leave our umbrella behind? We can use the answers to those what-if questions to help us decide if our solution is going to work. Which would be nice to know before we go flying off into the gorge, right? So, engineers identify variables, which are conditions or values that can be changed when they're looking at and testing solutions to a problem. And by asking yourself what-if questions, you can practice your engineering skills. What-if questions can help you identify variables when looking at a problem. Just don't ever ask yourself, what if I forget something that I've learned in Sabrina's awesome engineering videos? 'Cause that's definitely not gonna happen. Right, Catbot? Come on, bird. And yes! Crushed it. I just beat a level that I've been stuck on for like a month. As any good gamer knows, it takes the right move to win. One wrong move and poof, a possible win can turn into a loss. The same thing is true for engineering. Last time we were thinking about the moves we could make that would guarantee the solution to our getting across the gorge problem was a success. And that included identifying variables, or the conditions or values involved in the problem that can be changed. But what's the big deal? Why do engineers identify variables when they're designing and testing solutions to a problem? Remember, we can control some variables, like the height from which we drop a ball to see how high it bounces. But there are variables we can't control, like gravity. Whether a solution to a problem turns out to be successful or not depends on picking the right way to change a variable. The way something turns out, like whether a solution solves the problem or not, is called an outcome. So let's see how changing variables can change an outcome by playing a game. The goal of this game is to knock down a pile of fluffy pink marshmallows, and to do that, we'll launch Catbot into the pile using a slingshot. There are two variables here that we can control. We can change the angle of the launch, and we can change how far we pull back on the slingshot. If we change either or both of these variables, then we can get one of three outcomes. We can knock over all of the fluffy marshmallows, knock over some of the fluffy marshmallows, or miss the pile completely. Now, I don't want to be stuck on this level for another month, so I'm going for the complete knockdown outcome. Try number one, and I miss. Completely. Boo! So I'm going to change one variable, the angle of the slingshot, but I want to pull back on the slingshot just as far as last time, otherwise I won't be able to tell if the outcome of the second try is because I changed the angle or if I changed how hard I pulled. So let's see if changing the angle by pulling back just as hard as before gives me the outcome that I want, and score! Total knockdown. Now, if I wanted to, for my second try, I could have decided to change how hard I pulled on the slingshot. But if I did that, I'd have to keep the angle the same. Bottom line, engineers only change one variable at a time. Otherwise, we can't tell why a solution works or doesn't work. So engineers don't just identify variables for fun, although it definitely can be. They identify them so they can figure out which ones they can control. That is, either change them or keep them the same. And that's important to know because changing a variable can affect the outcome or result of a solution. So engineers change only one variable at a time when they test a solution, so they're sure of the connection between the variable and the outcome. Now it's back to my game. I'm coming for you, marshmallows. Problems, solutions.
Okay, so hopefully you guys enjoyed that part of the video. There's one more part that we'll finish up next week. So I'm going to be sending you the review sheet. So the questions are, what is a variable? So you can just type it up. It was in the video. True or false, variables can only be controlled by engineers. In the gorge example, what is the example they shared of a variable that can be controlled and then one that can't be controlled? True or false, we ask what if questions when thinking about all of the different variables. What is an outcome? Fill in the blanks. Engineers identify blank so they can figure out which ones they can blank. And changing a variable can affect the blank or result of a solution. So it should be pretty easy if you guys watch the video and jotted down some notes. Okay, guys, so that's your homework for this week. and we'll be back next week. Alrighty. Have a good day. Bye, guys.